In the previous lecture, we have computed the DFT of the discrete time sequence x of n is equal to 1, 2, 1, 2, and we found the result that x of k is equal to 6, 0, minus 2, 0. So this was the DFT of the given discrete time sequence. In this lecture, we will compute the IDFT of the sequence x of k is equal to 6, 0, minus 2, 0, and we will verify whether we are getting the same discrete time sequence x of n is equal to 1, 2, 1, 2 or not. So in the first lecture we have discussed about the IDFT, which is represented as DFT inverse of x of k, which is equal to x of n is equal to 1 upon n summation k is equal to 0 to n minus 1 x of k e to the power plus j 2 pi k n upon capital N. And for this question, DFT inverse x of k is equal to x of n will be 1 upon 4 summation k is equal to 0 to 3 capital X of k e to the power plus j 2 pi k n upon 4. So for the different values of k from 0 to 3, we will get 4 different values of x of n. So x of n will have the 4 values: small x of 0, small x of 1, small x of 2, and small x of 3. So we will verify the result and we will see that these values are 1, 2, 1, 2 or not. So let us calculate the first value, which is x of 0. For x of 0, my n will be equal to 0. So x of 0 will be equal to 1 upon 4 summation k is equal to 0 to 3 x of k e to the power plus j 2 pi k into, as n is equal to 0, 0 upon 4, which is equal to 1 upon 4. For different values of k, it will be capital X of 0 e to the power 0 plus capital X of 1 e to the power 0 plus capital X of 2 e to the power 0, which is equal to 1, plus capital X of 3, which is 1 upon 4. Capital X of 0 is 6, capital X of 1 is 0, then this will be 2 minus 2, and finally it is 0. X of 3 is 0. So it is 6 minus 2 is 4, 4 upon 4 is 1, which is my first discrete time sample. So let us calculate the second sample. For that, n will be equal to 1. So this will be x of 1, which can be calculated by the formula 1 upon 4 summation k is equal to 0 to 3 capital X of k e to the power plus j 2 pi k into 1 upon 4, which is 1 upon 4 whole into, we will expand the summation and it will be capital X of 0 e to the power plus j 2 pi 0 into 1 upon 4 plus capital X of 1 e to the power plus j 2 pi 1 into 1 upon 4 plus capital X of 2 e to the power plus j 2 pi 2 into 1 upon 4 plus capital X of 3 e to the power plus j 2 pi 3 into 1 upon 4, and it is 1 upon 4 capital X of 0 is 6 e to the power 0 is equal to 1 plus capital X of 1 is 0. 0 into this value is 0. Then minus 2, X of 2 is minus 2. E to the power, it will be 2, 2 and 4 get cancelled out. It will be e to the power plus j pi. And last one is X of 3 is 0 and whole value will be equal to 0. So it is 1/4 whole into 6 minus 2 into cos pi plus j sin pi, which is 1/4 6 minus 2 into cos pi is minus 1 and it will be 0. So it will be 6 plus 2, which is 8/4, which is my second sample, X of 1. Let us calculate the third sample for n is equal to 2. This is X of 2, which is equal to 1/4 summation k is equal to 0 to 3 capital X of k e to the power plus j 2 pi kn/4, which is equal to 1/4 capital X of 0 e to the power plus j 2 pi 0 into 2/4 plus capital X of 1 e to the power plus j 2 pi 1 into 2/4 plus capital X of 2 e to the power plus j 2 pi 2 into 2/4 plus X of 3 e to the power plus j 2 pi 3 into 2/4, which is equal to 1/4. X of 0 is 6, e to the power 0 is equal to 1 plus X of 1 is 0, 0 into e to the power something will be equal to 0 plus minus 2 into e to the power, so this is cancel out, e to the power plus j 2 pi, and finally X of 3 is equal to 0, so this whole term will be equal to 0. So it is 1/4 whole into 6 minus 2 into cos of 2 pi plus j sin 2 pi, which is 1/4 whole into 6 minus 2 into cos 2 pi is 1 plus j 0, which is equal to 1/4 whole into 6 minus 2. 6 minus 2 is 4, 4/4 is 1, which is my third sample. In the same way we will calculate the last sample for n is equal to 3. So the sample is X of 3, which is equal to 1/4 summation k is equal to 0 to 3 X of k e to the power plus j 2 pi kn/4, which is equal to 1/4 whole into capital X of 0 e to the power plus j 2 pi 0 into 3 upon 4 plus capital X of 1 e to the power plus j 2 pi 1 into 3 upon 4 plus capital X of 2 e to the power plus j 2 pi 2 into 3 upon 4 plus capital X of 3 e to the power plus j 2 pi 3 into 3 upon 4. Which is 1 upon 4 whole into x of 0 is 6, e to the power 0 is equal to 1 plus x of 1 is 0, 0 into e to the power something is 0 plus minus 2, x of 2 is minus 2, e to the power, this one get cancelled out, e to the power plus j 3 pi plus x of 3 is 0 and this will be 0. Now this can be written as 1 upon 4 whole into 6 minus 2 cos of 3 pi plus j sin 3 pi, which is equal to 1 upon 4 whole into 6 minus 2 into cos 3 pi is minus 1 plus j into 0, which is 6 plus 2, which is 8 upon 4, and the result is 2, which is my fourth sample, x of 3. So finally x of n is equal to 1 2 1 2, which is my discrete time signal. So in this way we can compute the IDFT of a given complex variable. Thank you.